Take our entire solar system from the Sunday to the edge of the Kuiper belt and let it fall into this object. It would disappear without touching the sides, not because of some theoretical impossibility, but because of the sheer scale of what lies at the heart of a distant galaxy, consuming matter at a rate that challenges everything we understand about how black holes grow. This is TON 618. The most massive single object ever identified in the observable universe. And it forces us to confront a fundamental question. How did something this colossal come to exist so early in cosmic history? When you picture a black hole, you might imagine an invisible sphere of darkness, silent and still against the backdrop of space. For many black holes, that image holds true, but TON 618 is not dormant. It is one of the most actively feeding black holes we have ever observed. And when a supermassive black hole feeds, it does not hide. It announces itself across billions of light years. Imagine looking down onto a vast spiral, a hurricane of gas and shattered starlight, spinning inward at velocities approaching the speed of light itself. This accretion disk is not simply hot. It is a furnace, operating at temperatures that strip atoms apart, where matter exists as a searingly bright plasma, glowing blue-white at its outer edges and bleeding into ultraviolet and X-ray wavelengths as it nears the event horizon. The disk emits light not from chemical reactions or nuclear fusion, but from pure gravitational violence. Particles collide at relativistic speeds. Friction becomes a form of annihilation, and the sheer intensity of the radiation outshines entire galaxies. And from the poles of the black hole, something even more extreme emerges. Magnetic fields twisted by the spinning disk launch twin jets of superheated plasma outward at nearly the speed of light relativistic beams that stretch for millions of light years, carving channels through intergalactic space and reshaping the structure of the surrounding cosmos. This is a quasar. The name is shorthand for quasi-stellar radio source, because when astronomers first detected them in the 1960s, they appeared star-like but emitted radio waves far more powerful than any star could produce. It took years to understand what they were seeing, not stars, but the brilliant cores of distant galaxies, powered by black holes devouring vast quantities of matter. And the light they produce is not just bright. It is a transmission that can cross the entire width of the observable universe and still register on our instruments. A lighthouse beam cutting through the dark, visible from nearly the edge of time itself. TON 618 is one of the most luminous quasars ever discovered. Its story begins in 1957, when astronomers at the Tonantzintla Observatory in Mexico recorded a faint blue point of light in the constellation Canes Venatici. For years it appeared unremarkable, but spectroscopic analysis in later decades revealed something extraordinary. The light was heavily redshifted, stretched to longer wavelengths by the expansion of space itself, indicating a source at cosmological distances. TON 618 lies more than 10 billion light-years away. The light we observe today began its journey when the universe was less than a quarter of its current age, during an era when galaxies were still assembling and the first generations of stars were igniting the darkness. At that distance, we cannot resolve the black hole itself. What we see is its quasar, a blazing beacon, radiating with the energy output of approximately 140 trillion suns. That is not a metaphor. It is a measurement of luminosity so extreme that the glare completely overwhelms the starlight of the surrounding galaxy, rendering it invisible to our instruments. But the quasar is only the signature. The true colossus lies hidden at its center. At the heart of our own Milky Way sits Sagittarius, a supermassive black hole with a mass roughly 4 million times that of the Sunday. Its event horizon, the boundary beyond which escape is impossible, measures about 24 million kilometers across, large enough to contain the orbit of Mercury with room to spare. For decades, objects like Sagittarius represented the upper limits of what we thought black holes could become. Then we found TON 618. It holds a mass equivalent to 66 billion suns. That makes it more than 16,000 times more massive than the black hole anchoring our galaxy. The event horizon of TON 618 spans approximately 390 billion kilometers. a sphere of absolute darkness so vast that light itself, traveling at 300,000 kilometers per second, would take nearly 2 weeks just to cross from one edge to the other. To put that in perspective, the average distance from the Sunday to Pluto is about 5.9 billion kilometers. You could line up our solar system 66 times across and still not bridge the diameter of this boundary. If you could somehow approach it, you would not see a solid surface. You would see a perfect circle of nothingness, surrounded by a ring of light bent and twisted by gravity photons, caught in doomed orbits, circling the edge before finally falling inward, silent and inevitable, and time itself would fracture. Clocks near the event horizon would tick slower than those far-away seconds, stretching into hours, hours into years, as gravity warps the very fabric of space-time around the boundary of no return. If TON 618 somehow replaced Sagittarius A, its gravitational influence would dominate not just the galactic core, but extend far beyond, reshaping orbits and altering the structure of the galaxy itself. This is not destruction in the violent sense. It is dominance through sheer gravitational authority. But here is where the science becomes unsettling. Black holes do not grow overnight. They accumulate mass gradually, consuming gas, capturing stars, and merging with other black holes over billions of years. There is even a natural speed limit to how fast they can feed, known as the Eddington limit. When a black hole accretes matter too rapidly, the intense radiation pressure from the superheated material pushes away the surrounding gas, effectively choking off further growth. This creates a bottleneck. Even under ideal conditions, a black hole can only grow so fast. To reach 66 billion solar masses in 3 billion years, TON 618 would have had to consume the equivalent of roughly 20 suns every single year, without pause, since the moment it formed a feeding rate that stretches the limits of what current physics allows. And yet, when we observe TON 618 as it existed over 10 billion years ago, it had already reached 66 billion solar masses. The universe at that time was barely 3 billion years old. That leaves an uncomfortably narrow window for this object to have formed and grown to such a scale. According to standard models of black hole evolution, there simply was not enough time. So how did it get this large? One possibility is that TON 618 began as a particularly massive seed, not from the collapse of a single star, but from the direct collapse of an enormous cloud of primordial gas in the early universe. These direct collapse black holes could have started with masses hundreds of thousands of times that of the Sunday, giving them a significant head start. Another hypothesis suggests that the feeding conditions in the young universe were far more extreme than we observe today. Dense gas reservoirs, frequent galactic mergers, and environments rich in material may have allowed black holes to grow far more efficiently, perhaps even bypassing the Eddington limit under certain conditions. But these remain open questions. What we know is this: TON 618 existed when the cosmos was still in its infancy, and its presence pushes the boundaries of our current understanding of black hole formation and growth. And here lies a deeper, quieter realization. When we look at TON 618, we are not seeing it as it is. We are seeing it as it was more than 10 billion years ago. The light that reaches our telescopes today is ancient, a transmission from an era when the universe itself was unrecognizably different. In the time it has taken that light to cross the void, entire stellar generations have lived and died. Galaxies have collided and merged. The distance between them has grown as space itself expanded, and TON 618 has continued to exist unseen, feeding in the darkness, growing larger in a present moment we will never observe. We have no way of knowing what it looks like now. We cannot send a signal fast enough to catch up. We can only observe its echo burning across the gulfs of space and time, a ghost of a younger universe still making itself known. And in that echo, we are reminded of something we rarely confront. The universe operates on scales that dwarf our comprehension. We measure our lives in decades. Civilizations rise and fall over millennia. But the light from TON 618 has been traveling toward us for longer than complex life has existed on Earth, longer than the first vertebrates crawled onto land, longer than the dinosaurs walked, longer than our species has had language or fire or the capacity to wonder. We observe these distant giants not to conquer them, but to understand the forces that shaped the cosmos we inhabit, to see ourselves not as the center of existence, but as a brief, flickering awareness within a universe far older, far larger, and far stranger than we ever imagined. We are passengers on a world that is itself adrift. And out there, in the silent dark, objects like Ton 618 continue their ancient work, unseen, unwitnessed, indifferent to our existence. Thanks for watching, and I'll see you in the next one.